Hi, I'm Lee Teschler with EE World and Design World, and I'm here with Ian Rensing from Renco. And I'm talking to Ian about the small clearances you're into as magnetic components get smaller and smaller, and specifically about the creepages and clearances that you got to have for safety reasons. Ian, you're kind of an expert in this. What kinds of issues do you run into when magnetics get really small and you have to keep clearances high because the voltages are high?
Yeah, so one of our big challenges with these housekeeping transformers, a lot of times it's offline flyback, and customers sometimes run into things where they have high pollution degrees, high overvoltage categories, and we need a lot of creepage in these applications, but the power level is small. So, for example, we may have an EE16 that only has to do a few watts, but you can see it's only 16 millimeters cubed roughly. Well, how are we going to add another 12 millimeters to space it out? And one of those options could be to add fly leads with a connector. Similar situation down here. We have this very small package capable of 15 watts, but again, we may want fly leads for space constraint. If I have to have a bobbin sticking out there, that's just eating up board space. With fly leads, I can have my secondary components stuck in between the leads.
Now, Ian, what's usually the safety standard that you have to meet for creepage and clearance on these things?
Well, there's many different safety standards out there as far as UL, IEC, and CSA is concerned. You know, a very standard creepage is about 6.4 millimeters. It just happens to be, but again, it depends on the application. If a customer's pollution degree 2 overvoltage category 2, it's pretty standard stuff for an offline voltage. But we have the case where a customer is connected to distribution and we just need 12 millimeters of creepage. So another place you might see that used where a customer does not want fly leads because it is in fact more costly to assemble, we have a vertical extended creepage bobbin where the plastic is actually extended vertically by 8 or 10 millimeters. Another scenario where the customer doesn't have the affordability to grow in height, we will then present horizontal extended creepage. So you can see some of these other packages here grow horizontally and take up more board space in order to get away from the live primary winding or core to achieve that creepage and clearance.
Are these standard packages or are these specials?
A lot of these packages are standard packages, but we are not limited to that. Some of these packages here are very special, where we take an existing mold and we elongate them to get higher power without paying high tooling costs. So that's very common. One other thing I want to mention, you see we have all these different packages with triple insulated wire. That's a little bit new school. We still have an old school approach where we wind transformers with margins on each side. This is another way to accomplish creepage and clearance, getting these margins inside the winding window.
So Ian, all in all, sounds like there's several options you could have. Can you summarize them for us?
Yeah, so basically what it boils down to is we have hand-placed fly leads. We have pre-formed fly leads where we pre-form them at the factory, so they just insert right into the board at the contract manufacturer or OEM. We have vertical extended creepage where the bobbins grow longer. We even have fly leads with little connectors. And then, of course, we have the horizontal creepage where it grows left to right. And finally, the margin wound transformer.
Good. That's an interesting lineup for solving that problem, Ian. I appreciate it.
Yeah, definitely. Thanks, Lee.
Thanks.